So we talk about the kinds of solid waste and the city trash disposal, and we focus on the landfill. And now I want to emphasize plastic contamination. And we use all sorts of plastics. Some of the soft plastics are easier to degrade, and the hard plastics takes forever to go away from the environment. So I post a funny picture here. My boy made this picture because he likes to play Plants vs. Zombie, and he likes this big head imp, or this zombie is called imp. So the zombie is wrapped in various difficult, not different clothes. It's very funny, but it's the same zombie. And here I put a plastic picture here, and we have all sorts of plastics in different appearances. But I want to tell you they are equally harmful to our health and the environment. So why plastics is so nasty? I put a chemical structure of estrogen here, which is a female hormone in everybody's body. Men has more hormone, androgen hormone, and the ladies have more estrogens. So I put a hormone structure here. If we compare the structure of bisphenol A and the beta estradiol, they are not very similar. But when they are arranged in a three-dimensional space, they can fit in each other's hormone receptors. Those are the proteins accepting those hormones and triggering a bunch of chemical reaction in our body and regulate our functions. So for a human body, we don't need a whole lot of hormones, right? A teaspoon for one person is enough. So when those chemicals come into our body and mimic like bisphenol A, right? That's the single blocks being built for the plastics. And when those things leaching from the plastic and enter our human body, they mimic the function of the hormones, which is very harmful. It can cause problems of cancers, reproduction problem, infertility, and a bunch of other disorders in animals' body and in humans' body. So that is why the plastic is evil. But unfortunately, we dump tons and tons of this stuff every year in the environment. And the plastic bottle, the bottle of water, right, generating the plastic, that is one example. But we use a plastic almost everywhere in a single day, every day. And I do have a point of emphasis that I will conclude at the end of this lecture. So the last thing I want you to know is recycling. And recycling is not as easy and straightforward as we imagined before. Here, I want to share a video with you.
Waste management is on a mission to drive environmental performance with solutions that manage and minimize waste, recycle valuable resources, and create clean, renewable energy.
They say one man's trash is another man's treasure, and here at Waste Management, we really believe that that is true. We've really had a shift in our mindset where people historically used waste as trash. Now we really view waste as a resource, and it's a material that we need to manage and find innovative uses for. Single-stream recycling really makes it much easier for the consumer or the user to do it on a daily basis. So whether you're a resident or at a commercial property, really all you need to do is put your paper, your plastic, your metal, glass, cans, all in one container, and our facilities will do all the work.
It's hard for me to come with any reasons why not to do single-stream recycling. The more people know about what we do, the better and the easier it's going to be to recycle. And that's the goal. Send it this way and we'll take care of the rest.
By making recycling easier, single-stream systems can boost recycling participation rates by over 50% and make the recycling collection process simpler and more efficient for residents, municipalities, and commercial customers. The Philadelphia Material Recovery Facility in Northeast Philadelphia exemplifies our commitment to recovering the value in waste. The 60,000 square foot facility was constructed using sustainable building and design techniques, which meet the LEED Silver certification standards of the U.S. Green Building Council. This innovative single-stream facility can process and sort more than 20,000 tons of recyclable newspaper, cardboard, aluminum, glass, and plastic each month, equal to the weight of 261 Boeing 737s. Customers who purchase recycled materials want them to be free of contaminants. They don't want plastic or metal mixed in with their paper, or paper mixed in with the plastic they've ordered.
The expectation is that we should be close to 100% purity in the materials that we're sending to our customers. We expect our machine to give us 95% of the quality. The extra 5% we do manually. We have all this technology, but at the end, our employees make the difference.
So I want to pause here for a second. For recycling, I want to emphasize the sorting and cleaning of the trash. And a lot of people probably think we just dump the trash into the recycling bin and then it go to a recycling heaven. No, it's not. It's very hard work. That's why everybody should sort and clean their recyclable trash before they put in the different bins.
Examine the single-stream separation process and how people and technology together produce a quality end product. A truck containing mixed recyclable materials arrives at the processing facility. After being weighed and recorded, the contents are emptied onto the tipping floor. The recyclables are loaded onto the main feed conveyor, which directs the material to several different sorting areas. In the first area, large rigid plastics, such as toys and buckets, are separated for baling and sale to plastic markets. Non-recyclable materials are discarded into the trash. The materials continue on to a series of disc screens. This specially designed separating equipment consists of rotating discs that push cardboard over the top. Larger pieces of cardboard are sent to a second conveyor for another pass to remove contaminants, and then to the baling process. Material that falls between the disc screens moves to the next sort area called the combination news screen, where paper materials are separated from household bottles and cans. The first section removes most of the newspaper, advertising inserts, and office paper, which is filtered onto a processing line, where any materials other than paper are manually removed. This product automatically falls into the final bunkers, which, when filled, is fed into the baler and prepared for customer pickup. The pre-sort and newspaper conveyor stations contain a series of air vacuums. These allow plastic bags to be removed from the line and sent to a separate bunker. Disc screens have sorted out paper and cardboard. What's left, steel, glass, plastic, and aluminum, is directed to a glass breaker to remove glass, and then to a paper magnet to remove any remaining paper and film plastic from the container stream. The glass is transferred by conveyor to an inside storage bunker. The containers exiting the glass breaker then pass under a magnet that removes all steel cans for baling. The remaining materials, primarily plastic containers and aluminum cans, are then passed under an optical scanner to remove light plastic containers, such as soft drink bottles. The remaining containers pass a manual sort station where additional heavier plastics are captured. These include clear plastic containers such as milk and juice bottles, and colored containers.
I want to pause here for a second, and you see how those workers standing there and sorting out the trash, and how quick their hands moving, and that is a very difficult job. And so to help other people's job easier, we should do a good job ourselves by sorting and cleaning the trash before we put in the recycling bin.
Such as liquid detergent containers. These products are also separated for baling. What's left, cardboard juice cartons or non-conforming plastics, pass under another optical scanner for removal. The remaining material goes through a magnetic field known as an eddy current to remove the aluminum, which is blown into a material storage bunker for baling. Any remaining material